Have you ever really stopped to think about language? You know, this stuff you're using in your head right now to understand me. It feels so easy, so automatic. But underneath that surface, there's this hidden world of rules and logic, this beautiful, complex machine that's always running. Today, we're going to go find that hidden code. So let's just dive right in with a pretty mind-bending question. How is it that you can understand a sentence that you have never, ever heard before in your life? I mean, what kind of engine is running in your brain that lets you do that? It allows for this basically infinite creativity. Well, the answer, at least at first, seems almost beautifully simple. All right, so here's the game plan. First, we're going to look at that beautiful, simple idea, what we're calling the dream of compositionality. Then, we're going to see how reality gets, well, messy and starts breaking all the rules. After that, we'll dive into the heroic effort to wrestle with that mess. And finally, we'll see why this whole unfinished puzzle matters so much.
So let's start with the dream. For literally centuries, philosophers and linguists have been totally captivated by this one really elegant and powerful idea about how language gets its meaning.
It's called the principle of compositionality. And the core idea is honestly super straightforward. It just says that the meaning of a whole sentence is nothing more than the meanings of its individual words, plus the rules for how you snap them together. That's it. Simple, logical, predictable. Probably the best way to get your head around this is to think about Legos. Seriously. Every word is like a single Lego block. It has a specific shape, a specific function. You know what a blue block means, you know what a red block means. And language is just the act of clicking them together. So, for instance, you've got a Lego block for the, one for boy and one for runs. You click them together in the right order and bam, you get a clear, totally unambiguous meaning. The boy runs. It's a brilliant way to show how meaning can be built up, piece by logical piece. And this whole idea is just so powerful. I mean, for a few big reasons. First, it explains our creativity, how we can build an infinite number of sentences from a pretty small set of words. But it's also the absolute foundational dream of artificial intelligence. If language is just logical blocks, well, then we should be able to teach a computer the rules, and it should understand us perfectly, right? It paints this picture of language as this clean, logical, predictable system. A beautiful picture that, turns out doesn't quite match reality. Yeah, because the messy reality of how we actually speak is kind of a nightmare for this simple model. It turns out language just loves to break its own rules. Let's take a look at our main problem sentence for today. On the surface, it seems totally fine, right? Every woman who loves a man kisses him. But lurking inside this very simple sentence is a little gremlin that threatens to tear down the entire Lego castle that we just built. And the problem is that tiny little word, him. Who is him? Now, our intuition, your brain, tells you the answer instantly. But for our simple Lego model, this is a huge, huge problem. Okay, so here's exactly where the Lego model just falls apart. If we follow the strict compositional rules, him is its own independent Lego block. That means the sentence should mean that every woman who loves a man goes and kisses some other random guy. But we know that's not right. Our brains instantly, without even thinking, connect him all the way back to a man. The meaning of one block is being changed by another one that's far away in the sentence. Suddenly, the pieces aren't independent anymore.
So let's meet our rule breakers. These culprits actually have names. First up, you've got quantifiers. These are words like every, most, or all that kind of set up a zone of influence across the whole sentence. Then you have anaphora. That's just the fancy term for pronouns like him, her, or it that refer backward to something that was already said. Put them together and you've got a recipe for chaos.
These elements just create total logical chaos. They cause what linguists call scope ambiguities and this thing called a destructive variable assignment problem, which is a complicated way of saying that the meaning of one part of a sentence can accidentally just overwrite or totally erase the meaning of another. The simple, clean system we started with, it's suddenly looking very, very messy. So, what happened? Did researchers just give up on the dream? Throw in the towel? Absolutely not. Instead, it kicked off this incredible intellectual quest to save it. This is a story of wrestling with meaning itself.
And you have to understand the stakes here were incredibly high. The challenges that these little rule breakers posed were so deep, so fundamental to the very logic of language, that for a while people honestly thought they were technically insurmountable. It really seemed like we might never be able to create a formal system to explain how we understand these sentences.
But rather than just abandoning the whole project, logicians and linguists, they doubled down. They started forging brand new, way more powerful tools from math, from logic, from computer science, all in an effort to tame the chaos and build a system that could actually handle the messy reality of how we talk.
And the solutions they came up with are, well, they're just genius. You don't need to get lost in the jargon here, but just appreciate the creativity. To fix the Lego model, they basically had to design entirely new kinds of Lego blocks. For example, some theories found a way to read the sentence's instructions in order, kind of like a computer program that processes one step at a time without getting confused. Others built more sophisticated Lego bricks with smarter connection points to stop meanings from overriding each other. And some even borrowed these super powerful tools from programming to handle all the messy side effects of language. All those dependencies and references that were causing all the trouble. This was a full-on intellectual assault on the problem, rebuilding the whole system from the ground up.
And that brings us to today and to this unfinished puzzle, because this isn't just some abstract academic game. Understanding these hidden rules has some really profound implications for every single one of us. This hunt for meaning has been going on for generations. It started way back with philosophers like Frege, who laid the groundwork. Then it moved to formal pioneers like Montague in the 70s, and it evolved again with something called dynamic semantics in the 90s. And that work is still going on today, with each new generation building even more powerful tools to get closer to the truth. So why does all this matter? I mean, really? Well, for one thing, artificial intelligence. Cracking this hidden code is the absolute key to building AI that can truly understand us, not just, mimic patterns. It's also fundamental to understanding the incredible computational device that we all have inside our own skulls. And on top of all that, it pushes the very frontiers of logic itself, forcing us to invent totally new ways of thinking about how meaning even works.
Which kind of leaves us with this one final thought. We use this unbelievably complex program, our language, every single day without a second thought. But when we actually try to pop the hood and read the source code, we find a system that's so much more powerful and so much more mysterious than we ever could have imagined. And the quest to finally understand it, it has only just begun.